Okay, we have a sort of gazebo arrangement in our garden, and it has in amongst it some LED lights, and this is the controller for the lights, which sits up on this block of wood somehow. I'll point the camera at it, and the mounting broke and it had fallen over, so that clip was my first attempt to fix it, which didn't work, and I got involved in other projects. So it sat on my desk, the controller sat on my desk for however long, but now it's into November and it's time. We had some twinkly lights in the back garden. So before I went any further with fixing the mounting for this thing, I thought we'd plug them in and check they work. So there we go, the LEDs go in the controller box there. Open the controller box up. Oh. No. So the controller box has a couple of good batteries in, it takes an alkaline and a rechargeable, a belt and braces. So that should be on, and if we cover the solar panel, it's only supposed to work in the light, we get absolutely nothing. Whatever we set it to, we get nothing. So either the control box is faulty or the LEDs are faulty. So should we, while we're down here out in the garden, just connect some batteries up to the LEDs and see if we can get them to light. Okay, so let's test these LEDs. We have some batteries, 4 of them. It should give us not too far off 5 volts. Okay, so rather dodgy looking connection to the plug at the end of those LEDs. So one guy goes to one end of these batteries. Let's see if we can get any light out of them. 1 battery, 2 batteries. That's actually 4 batteries, I think, and these are lighting dimly, and some of the others, those 2 down there, they're probably out of your shot, are lighting a bit brighter. So my current best theory is there is connection problems in these LEDs, which have been out in the elements for 3 years. Okay, however, let's go in and just check the control unit works okay. Okay, here's the control unit. It's got a little solar panel on the top to charge the battery up, and whoops, it's got some electronics and the control switch, and it's got an alkaline battery if you want to run it and they haven't had any sunshine to charge the rechargeable up, and the battery holders disintegrated on me. Okay, and to test it I have cobbled together essentially 2 back-to-back LEDs, a red and a green one, and 150 ohm in series with them. So should we just plug this in and see what happens? So that's that. Oh, that looks good. And what does this do? Oh, alternate. What does this position do? Both on. Is that it? Yeah, that's your lot. And if I pick it up and point it at the window, they go out. If I put put my hand over it, it fires up again. So that, on the face of it, seems to be working fine. So since we're here, let's connect up the picoscope and just see how it's driving these. Okay, so it's turned off and nothing on the picoscope, so let us turn it on to the first setting. Yep, now it can't turn them both on at the same time, so they're back to back, so it's just turning them on alternatively very fast. Make them appear as though they're both on at the same time. So let's try the next switch. Oh, there we go, and that's alternating them slowly. So you can see when one's high the other's low and vice versa. So, and if we look on the back one, that the last one, that's both on at the same time. So if they're around about a millisecond. Yeah, 2 cycles is about 2.5 milliseconds. So it's somewhat just under a kilohertz. Right, well, I think I can't put it off any longer. Go out in the garden and retrieve the LEDs, which have been tied in for 3 years and probably in amongst the greenery. Anyway, there you go. So here they all are. I've given them a couple of hours to dry out because they're all damp and soggy. So let us first, there we go, let's first just connect an ohm meter across them, and we get 50 ohms. That should not be. I don't think we should get anything, and if we put it on diode we get 57 millivolts, and they should be across a diode. For instance, if I connected instead to my little test jig, which is 2 back-to-back diodes and a resistor. No, turn the meter back on. Yep, nothing. It's not putting out enough voltage to turn the diodes on. Interestingly, if we go to diodes, yes, it's putting 1.8 volts, that's the maximum it'll put, and they need 2.2 volts to turn diodes on. So we conclude somewhere in here there is a short circuit. Let's untangle it and run some power through it and see if that gives us any clues as to where. Okay, started taping it all to the bench, laying it out so we can see it all. And while I was doing it, I noticed this particular point. I'll try and zoom us in on that nicely. There should be an LED across there, and in fact there are 2 LEDs broken off and the wires are shorted together. So that would, I think, cause our short circuit problem. So at this point I think it's still in the picture. I will fix this and then measure the resistance again. That may be the problem, so I'm just going to connect the wires and be 1 LED less, but there are 200, so we're not going to miss it. Okay, so here's the meter on ohms, regular ohms again. So let's connect that across there. Nope, still 66 ohms. Okay, there they all are taped down, and can't fit it quite all in the camera. However, I will move the camera if there's anything interesting to see. So, should we now connect it across the power supply? Oh, where are we going? Okay, voltage right down, power supply on. Turn the voltage up, so we need another camera pointing at the power supply. So, is this all on? Any of this on camera? That one appears to be blown. That one, that one, that one. Okay, so shall we get the controller unit and plug them in there. No. Okay, so it's the next morning and now we're measuring the resistance across our LEDs and we're getting 3.5 kilo ohms instead of 60 ohms. I suspect that is because wherever the problem was has now dried out some. So I'm guessing the problem is in one of the diodes that's blown, so I think I'm going to have a look at one or two of those, cut the insulation, it looks like heat shrink of some sort, off and have a look inside. But since that's gone up now, we might, you never know. Where are we? Oh, yes, a bit of metal in. Yes, we get some very, very dim lights. Okay. Right, we'll put them back on the power supply. Oh man. Ugh. And we will try and find the first one that's not working. Right. Just shoe up a bit, so we're the wrong way around for the first one, so we try 1, 3, 5, 7, 9. So the first row that way around work alright. Third, the first row that way around work alright. Alright, this one. So we have a look at this one. It's a bit burnt and grotty. This one should be lit because that one and that one should be lit. Alright, so here she is. Shall we try and cut this sleeving off? without cutting my finger, hopefully. Ah, gotcha. And what fun have we got in here? That's not a good idea. Blade back to front and pushing into the sharp end of the blade. Oh, she's off, and first thing that happens is the LED breaks off. So what actually is in here? So there is a jacket which is full of gunky corroded stuff. Though that little thing I think went a bit in here to separate the two wires, and there is the LED and the, I don't know whether you can see that, the two connections to the LED have just corroded through. Okay, so having dried them out, they've come back not too badly, most of them. So shall we see if we can get back to getting them working through the proper controller? So we have now a 100 ohms resistor in series with these, just a quick and easy way of measuring the current. So let's measure the voltage across the LEDs, which is that. So that's 2.86 volts. So now let's measure the voltage across the 100 ohm resistor in series with them. This wire. Which is off camera on the output of the power supply. 8.5 volts, which is 85 milliamps. Which, remembering we've got the best part of 100 LEDs on here, which is about a milliamp an LED, isn't too bad. And just as a final sanity check, we're going to kill the power supply. We're going to take this wire and the yellow wire, and we're going to measure the voltage, the resistance should I say. Alright, that was on AC volts, which is 370 ohms. Who knows? Who knows? So now we've got the picoscope across the output of the control box with nothing connected. So if I turn this on to there, that's the one we want. So that should be flashing alternate pairs of LEDs, and that is putting out about 5 volts a go into no load. And if we grab our little test circuit and just point that up at the camera, put that across there, we're getting about 3.5. And now if I plug the LEDs in, we get nothing lit, and it's down to less than 2, which is not surprising. There's nothing coming out because you need about 2 volts across one of these to get it to go. But according to our measurements, it was 2.86 volts across the LEDs, drew 85 milliamps, which is not unreasonable. There's 100 LEDs each way, even given some of them are blown up. So 100 milliamps total is 1 milliamp per LED. So are we back to saying there's something in the output of this which just isn't up to the job anymore? Okay, so I think it's probably time to just check that we don't have enough batteries in there. 1.47, 1.23, plenty of go in both of those. So it is time to have a look in this thing. Okay, so should we go into here? I notice there are some cobwebs down there. Go on, out of the way. So, what lives under here? What's that? That's cobweb. Ah! Okay, so here it is. The controller board. There is the, I guess that's the flashing bit under there, and this is the output. So this is a socket, and these double pins go to the socket, and I've scraped at it so you probably can't see. There was some stuff here, but I think it was just solder flux. It does look as though this side's being reworked. I don't know, at the factory. I remember their hand soldered the socket on. And so this has nothing written on it, so there's no chance of replacing that. So what I propose to do is simply dub the iron around these in the very faint hope that might help. And beyond that, I don't think there's anything we can do. So I will do that and bring you back. Well, there we go. I'll run the iron around those connections on the output for what it's worth. So should we put the battery back in? Turn this over, put the LEDs back in. Nope. The same. So I think I'm going to have to call that one a fail, sadly. And this is the manual for it. Coal and Bright. So it's a proper brand, and no, they weren't cheap. They were £20. They were not eBay, straight out of China. And it definitely says, it says citing the likes amongst foliage and trellis or twined round garden features. So you're definitely supposed to, they're definitely supposed to be outside. So here's the LED, and round it has this sleeve, which I guess is some kind of heat shrink. But at the end there are 4 wires going into the tube, so there are gaps around them, and because the wires are twisted, you string them up, and some point up, some point left, some point right, some point down. So there are bound to be a good number that are like that, and the rain just goes in there, down in there, and rots, corrodes the wiring, sure to create dirty water paths across, and in some cases corrodes through the wiring so they don't work anymore. So outdoors, as long as it doesn't rain much. So not so good for around here, and I think they actually really only lasted about a year. We sort of commented they weren't working and didn't do anything about it. So at least we've learnt a bit about lights. I think I shall buy some replacements, but I shall make sure I squirt something or other down the backs there to keep the water out, and they might last a bit longer. So, on that rather, I suppose, sad and disappointing note, we'll call it for this video. So it's goodbye from Triplicate, home of interesting electronics. Subscribe if you like us. Thumbs up would be nice. Comment if you know anything about twinkly outdoor lights. So it's goodbye.